Hello, in this video we are solving example to find the response of discrete time LTI system using Z transform. And the example is determine the response of discrete time LTI system governed by following difference equation. Equation is y of n is equal to minus 0.5 y of n minus 1 plus x of n when the input is unit step and the initial conditions is y of minus 1 is equal to 1 by 3. Now here input is given, that is unit step, means x of n is equal to u of n, and initial conditions are given. Whenever there is a initial conditions are given, we have to use unilateral Z transform. So unilateral Z transform with initial conditions, y of n is the signal, its Z transform is y of z, and when there is a time shift in this y of n, we have to consider the initial conditions to take the Z transform this shifted signal, and that is here y of n minus 1. So you have to start from y of minus 1, and this is nothing but initial condition plus z raised to minus 1 y of z. Now suppose for y of n minus 2. Here y of n minus 2, so you have to start from y of minus 2 plus z raised to minus 1 y of minus 1 plus z raised to minus 2 y of z. Now check here, y is small here. That means it is initial conditions and time domain. And here y is capital means it is z domain. Similarly, y of n minus 3. So it will start from y of minus 3 plus z raised to minus 1 y of minus 2 plus z raised to minus 2 y of minus 1, and now z raised to minus 3 y of z. So like this, whenever there are initial conditions given in an example, you have to consider initial conditions. That means we have to take unilateral Z transform. Now let's solve this difference equation. Given data is this difference equation plus input is given unit step, that means u of n. Then initial conditions y of minus 1 is given, and that value is 1 by 3. Now let's solve this difference equation. Apply Z transform. So while applying Z transform, we have to use unilateral Z transform because these initial conditions are given. So y of n Z transform, then Z transform of this first term plus Z transform of this second term. Apply Z transform. Y of n Z transform is y of z. Now Z transform, this minus 0.5 we are taking outside, and Z transform of y of n minus 1. Z transform of x of n is x of z. Always Z transform we are referring by capital letters. Then Z transform of y of n minus 1 is initial condition y of minus 1 plus z raised to minus 1 y of z. So put it here, minus 0.5 as it is. Its Z transform is y of minus 1 plus z raised to minus 1 y of z plus x of z as it is. Now x of z is given. X of z is given. How it is given? Because x of n is given. X of n is u of n. And we know the Z transform of u of n. It is z upon z minus 1. That's why x of z is given here. So y of z is equal to minus 0.5. Y of minus 1, initial conditions are given, it is 1 by 3 plus z raised to minus 1 y of z, and x of z is z upon z minus 1. Now let's solve this bracket. So this minus 0.5 will come inside, minus 0.5 plus this z upon z minus 1. Now we'll combine the terms of y of z. So this term will take to the left side, and remaining term is equal to minus 0.5 is 1 half into 1 by 3 plus this z upon z minus 1. Take y of z common. So y of z common 1 plus 0.5 z raised to minus 1. So z raised to minus 1 we can write 0.5 by z and here 1 plus. So when we will solve this, it will come z plus 0.5 upon z. Y of z is equal to this 1 by 6 plus z upon z minus 1. Now we want to find y of n, response of discrete time LTI system. So this coefficient we will take to the RHS. So y of z is equal to 1 by 6 into this one, that is z upon z plus 0.5 plus z upon z minus 1 into z upon z plus 0.5 is z square upon z minus 1 z plus 0.5. Now we have to solve this y of z. We have to take the inverse of this y of z to get the y of n. Here for this one we can easily take the inverse. But for this term we need to solve it. So how to solve this? By partial fraction. So this term we will separately call it as a q of z. So q of z is equal to z square upon z minus 1 z plus 0.5. Once we will find this q of z, we will put it here, that is in the equation A. So let's solve this q of z. So whenever we want to find the q of z by partial fraction, always in case of z transform, partial fraction will take for q of z upon z. So this z will, one z will take the LHS and it will q of z upon z is equal to z upon z minus 1 z plus 0.5. Now here you can apply partial fraction method, that is a upon z minus 1 plus b upon z plus 0.5. So a, how will calculate a? A is q of z upon z into what is in the denominator z minus 1 for z is equal to 1. So q of z upon z is this one. Z upon z minus 1 z plus 1 into z minus 1 or z is equal to 1. So z minus 1 z minus 1 get cancelled and z is equal to 1. What you will get? Z is equal to 1 here, 1 upon 1.5 and that we can write as a 2 by 3. Similarly B, q of z upon z into what is in the denominator z plus 0.5. Now q of z upon z is z upon z minus 1 plus z upon z minus 1 into z plus 0.5 into z plus 0.5 at z is equal to minus 0.5. So this z plus 0.5 will get cancelled and z is equal to minus 0.5. Let's put it and what you will get? 1 by 3. So A is 2 by 3, B is 1 by 3. So q of z upon z we got A and B values. Let's put it. Now this z you can take to the RHS and q of z is equal to 2 by 3 z upon z minus 1 plus 1 by 3 z upon z plus 0.5. Once you get this q of z, let's put it in our equation A. What is equation A? Equation A is y of z equation. So this is q of z and we have to put this q of z. So q of z is, just we calculated 2 by 3 z upon z minus 1 plus 1 by 3 z upon z plus 0.5. At this stage, you can easily find the inverse of this one to get the y of n. So apply inverse z transform. Y of n is equal to inverse z transform. Whenever we are applying, we know a raised to n u of n is z transform is z upon z minus a, where mod z greater than mod a. So for z upon z minus a, inverse is a raised to n u of n. So here z upon z minus a we want. So z upon z minus minus 0.5. So a is minus 0.5. So your y of n is equal to minus 1 by 6 minus 0.5 raised to n u of n plus z upon z minus a. Minus is here, so a is 1. So 2 by 3, 1 raised to n, a raised to n u of n plus z upon z minus minus 0.5. So a is minus 0.5. plus 1 by 3 minus 0.5 raised to n u of n. Now if we'll observe this complete response, this response is because of initial condition y of minus 1, and this response is because of your input x of n is equal to u of n, unit step. So your y of n is a combination of two input, that is, first one is zero input response. The response because of initial state only, it's called as a zero input response because we are not considering the effect of x of n, and it is also called as a natural response or a free response and denoted as a y of zi, zero input response. Similarly, this response is because of x of n input. At that time, we are not considering initial conditions. That's why it is called a zero state response or forced response. And total response is combination of these two. That is output because of initial conditions, initial states, and output because of input signal. So this combination is nothing but total response of discrete time LTI system. We can solve it now. Combine the minus 0.5 raised to n u of n term. So minus 1 by 6 plus 1 by 3 you have to solve, and this remaining term is here. We have combined these two terms. Minus 0.5 raised to n u of n we have taken common. So minus 1 by 6 plus 1 by 3 and this term. So solve this. Minus 1 by 6 and this multiply and divide by 2 to get 1 by denominator same. So you will get 1 by 6 minus 0.5 raised to n u of n and this term as it is. So this is your final response or response of discrete time LTI system. Thank you.